You're in the midst of a really tough workout in the summer sun and are really sweating up a storm. How is your body adjusting to your water loss via sweat in order to maintain homeostasis in your body? Let us start with a few basic terms so that we may explain how your amazing body reacts to this excessive sweat loss. First, blood osmolality is the number of moles of particles per kilogram of solvent, which in this case is the electrolyte water balance in the blood. Secondly, osmoreceptors are sensory receptors that detect changes in osmotic pressure. Next, we have a hypertonic solution, when the concentration of solutes is greater outside the cell than inside. This occurs during dehydration. Finally, osmotic pressure of the human body. This is the force a dissolved substance or solute exerts on the movement of solute across a semipermeable membrane. The concentration differences on the semipermeable membrane create osmotic pressure. Next, we will discuss the hormone involved in this regulation process, ADH, which is antidiuretic hormone. This hormone is going to come to the rescue to increase water reabsorption in the kidneys. Essentially, ADH activity is stimulated by those embarrassing armpit stains. This is because excessive sweating causes water loss and increases blood osmolality. An increase in blood osmolality begins to create a hypertonic condition. This then stimulates the osmoreceptors in the hypothalamus. Osmoreceptors respond to the increased blood osmolality by stimulating the next factor in the telephone line, the pituitary gland. Here is where antidiuretic hormone comes into the picture. The hypothalamus acts on the pituitary gland to stimulate the secretion of ADH into blood circulation. ADH, of course, acts on the kidneys to increase water absorption so that the water absorbed can be returned into the blood circulation. In this way, the water and blood volume are kept at homeostasis. To recap, our stimulus is water loss, which causes increasing blood osmolality, which acts on osmoreceptors in the hypothalamus of the brain, which then stimulates the release of ADH from the pituitary gland, ultimately causing the kidneys to increase water absorption so that water can be recirculated into the blood. Now, what would happen in reverse? This would be if you would overconsume water. Although this case is rare, it is certainly possible, especially in endurance athletes. Excess water consumption results in an excess serum water concentration, and ADH would react to a decreased blood osmolality by a decreased stimulation of water uptake by the kidneys and an increased excretion via urination. The body's osmoreceptors in the hypothalamus would detect a decreased blood osmolality and the hypotonic plasma solution in the body.